At this point in time, we'll move on. Okay. Now we're going to look at something called polyatomic anions. Polyatomic anions have more than one atom. Excuse me, I don't know what happened there. Polyatomic anions have more than one atom that makes up the ion. Poly, many. They usually end in ate or ite. They're usually what we call an oxyanion. They've got oxygen in them, and the oxygen gives them the ate or the ite. You treat them as if they're in parentheses. We're going to look at a few here in a minute. I talk about a beast in a cage, the parentheses, beast in cage. You want to keep these together, and you treat it as a single unit, just like we did. You can utilize the cross method for that. Some examples of common polyatomic ions are nitrate. There's your 8. Nitrate is a nitrogen with 3 oxygen attached to it, NO3, with 1 minus charge. Nitrite is NO2 with a 1 minus charge. Sulfate is an SO4. Only this time, this beast I talk about has 2 minus charge. Sulfite is SO3, still with the 2 minus charge. These are some of the biggies that we use all the time. 8, ite. Phosphate, trying to predict, is the PO4. This time it's got a 3 minus charge. Now, if we're trying to predict here how many oxygen there should be, if you look, the 8 in this one has 3, ite has 2. In the sulfate, the 8 has 4, the ite has 3. The ite version always has 1 less oxygen than the 8 version. And there's some other rationales as to how we name them. We'll get some more rules in as we get a little more sophisticated. But for now, just accept that the ite has 1 less oxygen than the 8s. These are the big 6. These are really the 6 ones that we talk about and use the most in class. There are some exceptions to this ite and 8. Hydroxide is a polyatomic ion that ends in IDE, just like those monatomic cations before. Hydroxide is an OH 1 minus charge, hydroxide. Notice all of these also are anions, so the negative. We do have one exception. I have it listed under the anions. It really should be a cation. It is one of the few polyatomic cations. Let me write down here that this is a cation, not an anion. One of the few polyatomic cations we have, and it is NH4 1 plus, the ammonium ion. It sounds like ammonia. Ammonia is NH3. Ammonium is NH4 plus. So when we use these, as it says back here, make sure you keep it all together, and you want to treat it as a single unit. So keep the beast in its cage for now. All right, and you treat it just like if it's its own entity.